Okay, hello everyone. In our last class, we have been discussed in detail about system of matrix of an optical system. Considering this case, the system of matrix of whole system is the multiplication of these five matrices. Particularly, if we are going to consider the system of matrix of this thick lens, then the system of matrix will be the multiplication of these three matrices. One is your refraction, again this is your translation matrix, and another one is your refraction matrix. After multiplication of these three matrices also we can get the 2 cross 2 matrix. So in general, a system of matrix of an optical system is represented as this way: 2 cross 2 matrix. A, B, C, D are the four elements of that matrix. In general, it will be represented as this one for any optical system. Also, we have been discussed that the system of matrix of an optical system will be acceptable if and only if the determinant of system of matrix is unit. That means if we have a arbitrary matrix, 2 cross 2 arbitrary matrix, and its determinant, if we are going to calculate, if it will be 1, then it will be considered as or accept as system of matrix. Otherwise it could not be accepted as the system of matrix. Based upon this concept, we solved a question and we found this matrix. B matrix is your acceptable system of matrix. In our today class, we are going to discuss this one: cardinal points and cardinal planes of an optical system. Okay, particularly in this class, we are going to discuss what are the cardinal points present in an optical system. In our next class, we are going to discuss location of cardinal points and cardinal planes. Okay, so let us start today class. Here, heading I given that cardinal points and cardinal planes of an optical system. In figure, this is your optical system. This one, this in between these two curve, optical system is present. Okay, and this one, x dash is your uh, principal axis of this optical system. What is the principal axis? The principal axis is the axis of symmetry of an optical system which coincide with the center of curvature of an optical components of the optical components. When light ray propagate along the principal axis, it will move without any deviation. So here you can see one convex, here this side is one convex surface, this side a concave surface, and its center of curvature suppose will be here, and its center of curvature will be suppose here. So x dash or the principal axis is the axis will be passed through in such a way that it will give the symmetry of the optical system. So if this is the optical system, this is the axis will pass through in such a way that it will give the symmetry. This half and this half has to equal, and also it has to pass through the center of curvature. Okay, center of curvature. And if a light ray will pass along this principal axis like this, it will move from object space to image space without any deviation. Without any deviation, it will move like this. This axis is called as your principal axis or optical axis. Okay, so here for any optical system we have found 6 cardinal points. 6 cardinal points or 3 pairs of conjugate points. So what are the conjugate points or 6 cardinal points? First, second focal points, first, second principal points, first and second nodal points. First we are going to discuss where or what are the first and second focal points and corresponding focal planes. Here, as we discussed, x dash is your optical axis or principal axis. Optical system present in between these two surfaces. This one is one surface, this one is your another surface. In between these two surfaces, the optical system is present. Suppose you consider this is a thick lens. Okay, here if I'm going to consider the first focal point where it will be located, First focal point is a point in object space. Space means this side. On the principal axis. On the principal axis means on the x dash line. Principal axis of the optical system, from which when light ray starts and after refraction through optical system, it becomes parallel to principal axis in image space. So here, suppose we are going to consider this is the point f1. When the light ray starts from f1 in your object space, refracted with optical system. Here refracted means first it will be interacted with A, then translated from A to B, then refracted at B and emerged parallelly. This ray BC is the emergent ray after refraction, which is parallel to the principal axis. So this point will be called as your first focal point. Same thing it has been written. The point is in the object space on the principal axis of an optical system, from which when the light ray starts and after refraction through optical system it becomes parallel to the principal axis in the image space. Here BC is the parallel line. Okay, then first focal plane, a plane which pass through first focal point f1 and perpendicular to principal axis. This one, this is the plane which is called as your first focal plane. This is the plane which is passed through the first focal point and perpendicular to the principal axis. Now we are going to move towards the second focal point f2. In figure, f2 is here. Here f2 is here. Okay, is the point in the image space. On the principal axis. Okay, when a light ray coming from object space and parallel to the principal axis, that means this ray LM coming from object space which is parallel to the principal axis, LM ray is the parallel to principal axis. After refraction through optical system, after refraction means it is interacted at M, again refracted and translated up to N, again refracted. So overally we can say after refraction through optical system, the ray will converge. See, after refraction through optical system, it will converge to that point. The ray converged to that point. That point means that point is called as your second focal point. That means if I am going to consider the reverse one, that means if the ray will be coming out from this point, okay, like this, after refraction through this optical system, it will be emerged parallelly with optical axis or principal axis. In either way you can define the second focal point, but here we have to remember the first focal point is in your object space, second focal point is in your image space. Second focal plane, the plane which will pass through second focal point and perpendicular to principal axis. This one, this plane passed through f2 and perpendicular to the principal axis is called as your second focal plane. Now we are going to move towards the first and second principal points. Here, first principal plane and first principal point. First we are going to discuss, then second principal plane and second principal point. First principal plane and first principal point. First principal point is represented by P1. The plane passed through S1. S1 means this point. Remember this point. And perpendicular to principal axis is called first principal plane. This one. This plane. First we are going to discuss first principal plane. Okay. Here first principal plane means the plane passed through this point S1 and perpendicular to principal axis is called first principal plane. So what is the point? How we can found the S1 point? Here S1 is the intersection point of undeviated F1 ray. So F1 ray means here from the first focal point the ray coming out, this one f1a. If we are not going to consider the refraction at a, the ray undeviatedly move along this way, a to s1. Okay, like this, undeviatedly it will move like this without refraction or without deviation. F1 ray and corresponding emergent ray, the intersection point of f1a means undeviated ray, f1, this one f1 ray, and uh, corresponding emergent ray bc is your, bc is its corresponding emergent ray, this is the bc ray. So if I'll extend this bc backward, this point s1 point is the intersection point between undeviated f1 ray and corresponding emergent ray. Through this S1, if I'm going to draw a plane which will perpendicular to the principal axis, that will be called as your first principal plane. See, you just remember the definition. You have to write by in your own word in your exam, because this question, if it will ask in your exam, it will ask for 3 to 4 mark. So you have to just draw the figure perfectly and locate the points and corresponding planes, and one line, just one line you just write by your own word. Okay, okay. So here s1 is the intersection point of your undeviated f1 ray and emergent ray bc. Okay, through this s1 the plane perpendicular to passed through and perpendicular to principal axis is called as your first principal plane, and its point of intersection with principal axis called the first principal point. So when the plane passed through this s1 point, also it will pass through the principal axis. So where it will pass through the principal axis, that point is called as your first principal point. Okay, okay. Similarly, we are going to define second principal plane and second principal point p2. The plane passed through s2 and perpendicular to principal axis is called second principal plane. What is the meaning? How to define s2? Here s2 is the intersection point of undeviated lm ray. lm ray means this one undeviated. If I am going to extend this lm ray, then it will be extended to like this. Okay, now, and corresponding emergent ray, that is your nf2. nf2 means this one. So if I'm going to extend this nf2 backward, then both the ray, undeviated lm ray and nf2 ray, both are intersect with each other at s2 point. So through s2, if I'm going to draw a plane which will perpendicular to principal axis, that plane is nothing but called as your second principal plane. And this plane also will be passed through or cuts the principal axis at this point, and this point will called as your second principal point. Same thing, it has been written second principal plane, and its point of intersection with principal axis is called second principal point p2. Now we are going to move to define first and second principal points, sorry, nodal points and corresponding nodal planes. Here, for this, to define nodal points and planes, we have to consider another figure, this one. So here, 2 points n1 and n2 called as your two nodal points of this optical system, which are on the principal axis, but if the incident ray will pass through the first nodal point, which is inside the optical system, the emergent ray, this one, has to parallel with the incident ray. So here Tn1 is the incident ray. When it will emerged from the optical system, then it will parallel with the incident ray. If the ray will pass through the first nodal point, then when it will emerge through the from the optical system, parallelly we can say that it is emerged from the second nodal point. Same thing, it has been written with these two lines. Here you can see n1 and n2 nodal points. N1 and n2 are two conjugate points, two conjugate points on the principal axis, placed in such a way that when the incident ray Tn1 directed towards one nodal point, it will emerge n2v here, into V parallelly to that of incident ray. Reversely also we can define, or we can understand in this way. If this is your incident ray, then this will be called as your emergent ray. This is one nodal point, this is another nodal point. Okay, and the planes which passed through these two nodal points are called nodal planes. Here these two planes passed through the nodal points and perpendicular, also perpendicular to the principal axis, perpendicular to the principal axis, are called first and second nodal planes. So here we discussed six cardinal points, or the three pairs of conjugate points which are present inside the optical system, any optical system. Okay, so here I am going to stop this class. In our next class we are going to discuss location of cardinal points and cardinal planes of an optical system. So thank you so much for watching this video. Thank you.